Good morning. This is Jim Pappas, and welcome to the Persistent Memory and Computational Storage Summit 2021. I'm a longtime member of the SNIA Board of Directors, and I work at Intel Corporation as Director of Technology Initiatives. And this is our 9th annual summit. I've been here with you at all 9, and this is one of my favorite events of the year. The first 8 were completely dedicated to persistent memory. And this year, for the first time, we're bringing in computational storage. And I think you're going to enjoy the conference quite a bit. Looking at SNEA, we're a large organization. You know, of the major organizations that drive standards, we're one of the larger ones. And we have about 180 leading organizations as members. We have about 2,300 active contributing members, and our reach is about 50,000 IT end users and storage professionals worldwide. We have our URL here, and feel free to come in, and if you like to learn more about SNEA, this is the way to come on in and learn a little bit more about what we do. We're proud of what we do. So we are about 20 years old, and we drive, as I said, a lot of standards. Some of them go into become other standards such as ANSI, ISO, and Insights, etc. And we also, for standards that we don't develop, we also take technical positions and to really provide the guidance and the outlook that the storage industry really needs. Inside of SNEA is a subgroup called CMSI, and that's the group that is sponsoring this summit. It stands for the Compute, Memory, and Storage Initiative. And we are a group of engineers and professionals who are working to combine multiple technologies in new and interesting ways. You know, we started with combining storage and memory with persistent memory. We moved on now to computational storage, and we believe that this is going to be some of the key trends that happen across the industry. And as we look forward, we think that CMSI is really going to be defining much of what future architectures look like. So back to this, it's the persistent memory and computational storage in one conference. So why are we doing this? Well, to answer that, let's first back up a level and go to the organizational level. So last year we were the Solid State Storage Initiative. And you know, why do we change over to the compute, memory, and storage group? Why did we change our scope to such a significant amount? Well, I hope this diagram helps talk about it. You know, if you look to the left and the right, we have memory and we have storage. And persistent memory bridged that gap and created new technologies that impacted and took advantage of both of them. So for instance, now there are new storage devices that are built using persistent memory technology, which gives much higher performance and much more consistent performance, you know, from cycle to cycle. So we have better storage devices available in the industry. Also, we have memory that takes advantage of the storage capabilities. Using the same persistent memory media, we're able to create both memory that has the persistence, like storage. We're also being able to build storage devices that take advantage of the faster media. And the industry wins when this happens. More recently, we started working on connecting storage and compute elements. You know, signified by the server in the bottom corner here, at the bottom of the page. And that's the computational storage element. And pulling these together became obvious, in part because a lot of the underlying technologies, and we'll talk more about that later, but the underlying technologies that we use to do both of these do overlap in some key areas. So you'll see a lot today and tomorrow about computational storage as the new element of this. Now, we don't really have a computational persistent memory program quite yet, but it doesn't take a rocket scientist to project that this is probably going to be the third leg of this three-legged stool. And, you know, as computational storage becomes more predominant, the computational persistent memory, I believe, will follow, and will follow quickly. I do believe that you will see this especially take off in the large cloud infrastructures where the scalable problems are most prevalent. So that's where I expect to see heterogeneous computing take place. And I think all three of these technology transitions, persistent memory, computational storage, and eventually computational persistent memory, will all become really important pieces. And we believe that here at SNIA, we're really driving this forward. So a quick update on what's been happening in persistent memory since the last year. Well, the persistent memory model is now, it has become very mature. So we have native support in Linux and Windows. And as we've talked about, this has always been our #1 priority. We realized that persistent memory is new. And if we let it become just the Wild West, every operating environment would have done things in very different ways. And that would have been horrible for the application developers because they wouldn't be able to build applications that were portable. Because of the ubiquity that this programming model became, and we look at the Linux and Windows as an example. You know, even the APIs that they use are nearly identical. Many of them have the same, you know, basic names to them. So whatever support you would likely have in one, there's a corresponding support in the other. And this is going to be a huge deal in terms of making the industry become adopted. Continuing work happens on remote persistent memory, and we sometimes call that RPM. And that work has been happening both inside of our own organization and across to other orgs, like the InfiniBand Trade Association and the Open Fabrics Alliance. Those of you who remember hearing talks from Tom Talpe from Microsoft at the time, Tom is now retired, but he's still at work, working in the IBTA groups, trying to complete the work for remote persistent memory in that area. We also have a long time working relationship with Open Fabrics, and that work continues and continues to make progress. So persistent memory becomes much more valuable when you could also introduce remote persistent memory so that you could take the data that's stored and share it across a larger number of nodes for greater reliability and better resiliency. So fairly significant updates since last year. Persistent memory products are now being deployed, and they're being deployed in pretty reasonable numbers. I don't work in the product group at Intel, but I get to see reports every now and then where there's design wins and customers are starting to introduce persistent memory products. And it makes me feel good because this has been a really tough project. To see these being developed and deployed is rewarding. And we finally getting some better interfaces to be able to attach persistent memory devices. So, one of the inhibitors to adoption is really the only place today where you could deploy persistent memory is on the DDR interface. And the DDR interface is really made for DRAM, which is a very predictable, never wait states. You count down the clock cycles and the data is available. And if it's not available, the machine doesn't work. So it's one of the most stable synchronous areas of the system. And persistent memory does not have that same level of synchronous behavior that DRAM has. So putting it onto the DDR interface required modifications to the DDR bus, and it makes it more difficult. It makes it more difficult to scale, and there's new technologies coming along now. The most probably important, the one to look at the most seriously was CXL, and stands for Compute Express Link. And I happen to be the chairman of the CXL consortium, so I know a little bit about this. So we just released, and I mean the CXL consortium just released the CXL 2.0 specification in Q4 of last year, and that has completely supports everything that's necessary for persistent memory. So new persistent memory media that becomes available now has a place to be deployed on almost every platform, because another thing is that virtually every new CPU architecture and existing mainstream CPU architectures are also implementing CXL. So this is going to remove one of the largest barriers to persistent memory deployment. So we have an agreement also. CMSI and the CXL organizations have a liaison agreement in place. And in fact, they are making 2 presentations at this summit. One is a presentation, I believe it's tomorrow, and a second presentation is actually a panel, and I believe that's at the end of the day tomorrow. Both should be very good. Also, Andy Rudolph, who's probably the godfather of persistent memory. He's the chief architect who really brought this idea to SNIA. He's doing a talk this morning on the implementation of persistent memory support in CXL 2.0. So that's something you don't want to miss. And then finally, what we're doing in CMSI and on the persistent memory front is continuing our educational efforts and the ongoing sponsorship that we have for the hackathons. So I have a slide for this. So we have a picture of here coming into these hackathons. They're a lot of fun, very geeky, and a bunch of engineers sit down. They go through classes and learning the differences between programming to, normal file systems, and then programming to having persistent memory, and what opportunities are unfolded in that. We've had a number of these things. Jim Pfister, who works for CMSI, he's been running these. There's one that's going on in parallel with these sessions here at the summit. And we have 3 more this year for 3 SDCs in CSA, EMEA, India, and the US. As we've gone through the pandemic, we've had to do these virtually, and it's become easier to deploy them. So I'm pleased to be able to announce that we have some new capabilities. You could host your own virtual hackathon if you'd like. So, get together with your favorite friends or whatever, and decide you want to learn how to program persistent memory, and contact us. There's a URL here at the bottom, and you will be able to, we can set up a hackathon for you. We can give you support. Our persistent memory systems are now hosted in the cloud, and we could give you, access to those so that you could work on them and continue to work on them and test your applications and see where this can take you. The other thing you might consider is your company. If your company is interested in getting involved with persistent memory, we could do company-specific hackathons as well. And I'm going to throw out the idea that even if your company has no idea that they would ever want to do anything with persistent memory, I still recommend that you may want to consider setting one up for your company just to get that base level training across some of your key engineers, your software developers. And you never know what's going to happen. It's very well, you could be sitting in a scrum sometime, a year from now, and trying to figure out how to solve problems or how to make your system work. And, one of the engineers could maybe come up and say, wait a minute, remember when we did this PM hackathon? If we were to use persistent memory, we could probably speed this thing up by 10x or whatever the figure is. So you never know what it's going to spark, what kind of innovation in the future. So recommend, what do you have to lose? So, okay, moving on to the overall event. This is the schedule for today. It's an all-day event. And I want to take your focus over here on the right-hand side. There's 3 columns. The first one in light blue, those are sessions that are primarily PM focused. If you look at the sections in red, those are primarily computational storage focused. And the ones in purple are ones that are designed actually for both. So I encourage you to actually, branch out. Even if you're here just for CS, look and see what happens with PM. You might, and vice versa, by the way. There's a lot of good training that's going to go on here over the next 2 days, and experiment, explore. You never know how this might change. Maybe it makes an inflection point on what you see and what you want to do going forward. Here's tomorrow's, same color coding applies. And I think we've done a pretty good job of balancing out to have this, this really dual themed event for both persistent memory and computational storage. Next, I'd like to thank our sponsors. Everything that we've been doing on persistent memory and computational storage is been free to all of you who want to participate. We have, to operate in the working groups, you need to be a member of SNIA, but we do the training we do, the webcast, the promotion, the hackathons, etc. All of those are free. We've never charged for one of our PM summits, or now it's virtual this year, but you get the idea. They've always been free. They've always had great interaction. So first, I'd like to thank our different categories of sponsors. We have our underwriter sponsor is CMSI. We have 3 platinum sponsors, Identicom, FutureWay, and MemVerge. And we have 1 gold sponsor with Smart Modular Technologies, and a silver sponsor, NGD Systems. And once again, without our sponsors, we would not be able to do these programs. So thank you to our sponsors. And finally, I'd like you to join us at the upcoming events that we have this year. We have 3 SDCs planned. Our main US event is in September. That may be virtual, it may be hybrid, it may be in person. We really don't know yet. We'd love to be able to do it in person, but it's not clear we can. But if we could, we'd love to do it. It's about the time we think that things will start opening up Whether or not we could do large events, I think, is still questionable. We have one coming in August in India and this June in EMEA. So please take advantage of those. And if you'd like to attend, speak, or sponsor, there's the URL on this page. So that concludes my talk. So enjoy the event, socialize. There's Slack channels that you could join. You could interact with each other, asking questions, make it dynamic. Let's make this a great event, and let's make persistent memory and computational storage happen out there in the industry. So thank you very much for attending. Once again, this is Jim Pappas, and I'm thrilled to have you here, and I'm thrilled to be able to welcome you to this conference. Have a great day.